There we go. Hello, everyone. Welcome to Pirate Science. Hello, Aiden. I think is that who's Dagger? Could be Dagger. Hello, Dagger. Scarlett, Austin. Enya, hello, guys. How are you doing? Happy Tuesday. My goodness, guys. For me, it feels like the days are just kind of blurring into one. So sometimes the only thing that helps me remember what day it is that it's Pirate Science Day. And in fact, I'm forgetting something. What am I forgetting? What am I forgetting on Pirate Science Day? Be right back. Let me go get it. There we go. Much better. Much better. Gotta be a pirate on Pirate Science Day, right? Okay. Let me turn off my chat there. Okay. So today we are going to talk about what makes pirate ships float. And we have a very classic physical science experiment that you can run at home and share some of the results. We can have a little competition today. Okay. So we're going to talk about what makes things float. How do pirate ships float? How do sharks float? How do humans float? How does a beach ball float? And why do some things sink? Why does a big giant aircraft carrier made of steel float and maybe a tiny little penny does not float? We're going to find out today. Today's learning target is I can engineer something that will float. So you're going to be building something today that will float. Okay? So let's see. Oh my goodness. What is my chat saying here? Hello, Lennon. Hello, Aiden. Chloe. Hey guys, how are you doing? What's my Minecraft server? If you want to get to my Minecraft server, you got to go to my website, mrincorvia.com, and the Minecraft server information is right there, okay? Okay, I feel like I could just have a 24-hour stream that just is, how do I get on your Minecraft server? All right, so let's take a look at what we're going to do today. So we're going to talk about why do things float? Why do things float? And the first thing we're going to do is we're going to have ourselves a little experiment. Now this is a very classic physical science experiment. It's like, in terms of classic science tests, like experiments when you think of school, I think of the most famous is, of course, can you make the baking soda volcano, right? That's classic. You know, maybe we should do that. We should have baking soda volcano. Would you guys like to see baking soda volcano? Hello, Harper. And hi from Jesse's crew. Oh, well, hello, Jesse's crew. Is that everyone in Jesse's crew watching today? That's good. Okay. But right after baking soda volcano is how many pennies can you float? Okay, so what are you going to need today? You're going to need some tin foil. You're going to need a big bowl. You're going to need some water. And you are going to need a bunch of pennies. Now, probably some of you have done this. In fact, I see Austin says, oh, I've done that with Austin. That is not how you spell done. But some of you have done this experiment before, but we're going to do it together, and then I am going to explain why things float or why things sink. I'm going to show you with some really incredible Captain Richard art. Okay? And then you will try to make more pennies float than me, knowing why things float or don't float. Okay? Sounds like fun? All right. So let me flip my camera here. Okay, so here we go. I got my pennies over here. I have a big bowl for water. Okay, and I have my Reynolds Wrap brand tinfoil. And I'm just going to open this guy up because this is a brand new tinfoil. I'm going to try to not cut myself on the sharp part. There always seems to be, I always cut myself in the sharp part. And what you're going to want to do is you're going to want to tear off about, so let's see, there it is, right? About this much. Look, guys, see how much I'm pulling off here? Okay, let's move my bowl for a second. Have some more room. And now you're going to want to take your tinfoil and you are going to want to take a pair of scissors and get yourself a ruler, okay? Now this is important because we want everyone to work with the same amount of tinfoil. Hello, Sky, good to see you here. Now what we're going to do is we are going to measure out, oh, I got my ruler upside down here. I want you guys to measure out 10 centimeters. Okay, so the centimeters are the smaller units, okay? Not inches, this is science class, we're using centimeters, okay? So 10 centimeters, here's 10, okay? So we are going to start by putting the 0 at the corner, okay? And then we're going to find 10 right here, okay? Now I'm going to make a cut. Let me line this up better for me. So we're going to cut out 10 square centimeters. Okay. Let's see, was that 10? There we go. So 10. All right. And now we're going to do 10 this way too. So that way we have 10 square centimeters. Go this way. So here's 10. Going to, you can like draw a line in your tinfoil. Okay. And then we can just cut that. Okay, get rid of my extra tinfoil. So now I have a square 10 by 10, which means we have centimeters squared. Get it? Square. So we have 10 centimeters by 10 centimeters a square. Okay? There we go. Now what you're going to do is you'll take this, let's put this aside right now. Now I'm going to get my bowl. Here's my bowl. I don't need my ruler anymore either. So here's my bowl. And we are going to fill this bowl with some water. Okay, you want a nice large surface area of water here. Okay, you can see this bowl is about as big as my hand. All right, and we have a big large surface area of water. So now here is our tinfoil, and if we put the tinfoil right on the water, you can see that it floats there. It does not sink to the bottom. See, there it is floating on top. Okay, And what we're going to want to do is we are going to want to see how many pennies we can float. Okay? So here are my pennies. I'm going to take one. 1 penny. We're going to lightly put it in the middle of our tinfoil here. 1 penny. 2 pennies. 3 pennies. Before I do more than 3, type in the chat how many pennies you think it can hold. How many pennies before it sinks? How many pennies? 3? Well, we're already at 3. So you think that the next one will cause it to sink? How many pennies? I'm going to guess 10 pennies. That's my guess. 10. Oh, Marcy also guesses 10. Good guess. All right, here we go. 4. Some water's getting on. Some water is getting on. Let me refocus this camera here. Maybe that will help. There we go. 5 pennies. Oh no! Water is on! Oh! No! 5 pennies. And then it sank. Okay? Let's talk a little bit about, now we're going to do this again, okay? But I want to show you a little bit about what I know about the way things sink and float. Now I'm going to need to switch my web around. So let me just open up my chat here on my phone so I can see you guys. Okay, here we are. Let me set chat up right there. Now I can see you guys. Okay, so we are going to, let's take a look at my incredible art skills. Okay, so here's a drawing program we're going to use to do some drawing. Micah asks, did you get my Gmail? I did. We'll talk about that at the end of class, okay? So here we go. Why did something float and why did something sink, okay? Actually, let me show you. Before we do the drawing, let me show you one more demonstration here of why something floats or sinks. I have here just like a jar, okay? And I'm going to fill this with water. You can do this at home also if you want, but really we're just doing the penny test at home. But this is fun to see. So here I have a jar of water, right? See? And what I'm going to do is I'm going to take this here. This is a ping pong ball. Do you think the ping pong ball will float or will it sink? What do you think? Ping pong ball float or sink? Here we go. So type in float or sink if you think it's going to float or sink. And we'll see. Okay, here we go. Science test number 2. The ping pong ball floated, right? Now, why? Why did it float? That is a harder question, and honestly, I bet you there's not a lot of adults who can answer this question either. This is a pretty difficult concept to understand, and I hope to show you today why. So, I want you to look at the water line right here. I'm going to push the ping pong ball under the water, and I want you to watch what the water line does. Ready? See how it goes up? Okay. Again, closely. The water goes up. when we push the ping pong ball in. Okay? So let's talk about that. What's going on here? And what does that have to do with floating or sinking? Okay? Let's go look at some incredible, beautiful, highly detailed Captain Richard hand-drawn art. All right, here we go. This is my favorite online image editor. It's called Pixlr. You can use it too. There's actually a link to this on my website. Okay, so let's say we have this here jar of water. Let me draw that. Okay, there's the jar. It's a side view. Okay. Give me 1 second. 1 second. 1 second. Oh my God, I'm back again. All right, let's go back to, I think, okay. Badoop. Okay, here we go. So here is my jar, right? And let's fill it up with some water, okay? Let's get some water. And we're gonna fill it up about that much water. Okay, so there's the water. Now let us draw ourselves a ping pong ball. This ping pong ball is going to be orange, okay? We're just gonna make it orange. Let's make a new layer. Okay, and we are going to draw a ping pong ball. Actually, all we have to do is make a big dot. Here's our ping pong ball. Boop. Okay? So what happens is when we take our ping pong ball and we put it into the water, it floats, right? Just kind of like that. See it floating there? And when we push the ping pong ball down into the water, what happens is the water level goes, it rises up. So it looks a little like this. Oh, too big. Okay, so when we push the ping pong ball down, the water level rises up like this, right? It like rises up overhead. Hold on, wasn't supposed to do that. There we go. Okay, right? So if we push the ping pong ball, so this light blue is where the water is. We put the ping pong ball in and we push it down. The water that rises up, this amount of water, this is called displacement. The water, the amount the water goes up, right? If we were to just take that water, like if we were to just take this amount of water, put it over here, right? And then we were to take our ping pong ball and put it over here. And we were to weigh them. So if we were to get a scale, here's like one side of the scale and here's the other side of the scale. And we have a balance scale like this. Okay, here's my beautiful balance scale. Is this beautiful, guys? You like powder better. Yes, the powder tool is awesome. In fact, I think we can do this in powder tool. If the amount of water that went up, this blue water, weighs more than the ping pong ball, then the ping pong ball will float. If the ping pong ball weighs more than the amount of water that it gets displaced, it goes up, then the ping pong ball will sink. That is the law of buoyancy. That's why things float. When the amount of water, the amount that it changes, if it weighs more, if that water weighs more than the object will float. Okay? That is why things float or sink. Okay? So when we go back to our pennies here, let me get our pennies out here. So when we have our tinfoil floats because when we put the tinfoil in, it pushes the water up a little bit. And that water weighs more than the tinfoil, so it floats. And as we add pennies, we start to increase the amount. When every penny we put on makes the water go up a little bit more and a little bit more. And eventually that water weighs more than all of the pennies and the tinfoil that is pushing up. And down it goes. Okay? So your challenge is this. Here is your challenge at home. I want you to take make a square of tinfoil, just like this one. Make a square of tinfoil 10 centimeters wide, 10 centimeters long. Okay? 10 centimeters. And I want you can do whatever you want to this. You can take this tinfoil and you can bend it, you can roll it, whatever you want to do to try to make a little pirate boat. I want you can tear it, you can rip it, whatever you want to do. I want you to try to make a pirate boat out of tinfoil. And everyone gets the same amount of tinfoil, 10 by 10. 10 centimeters by 10 centimeters. So here's just I'm just kind of rolling up the edges, try to make more of a bowl. There we go. And now we're going to have a little competition. Who can float the most pennies? So here we go. We got 1 penny, 2 penny, 3 penny, 4 penny, 5 pennies. Already I've done better than just laying it flat on the water. Let's get some more pennies. 6 pennies. 7 pennies. 8 pennies. 9 pennies. 8 pennies was the answer. Now I know you can do better. That's the whole point of this is can you do way better than me, right? So, that is what we're going to do today, all right? All right. So, that's the goal. how many pennies can you float with a 10 by 10 square pirate boat made of tinfoil? Okay? So remember, today was you can engineer something that floats. I want you to engineer a little 10 by 10 pirate boat, okay? And I want you to take a picture of how many pennies you have. How many pennies? Send me a message. Say, Captain, I floated 20 pennies. I floated 7 pennies. Whatever it is, tell me how many pennies that you floated in your tin pirate boat. And we will share that next week on Pirate Science. Okay? Good job today, guys. I hope that you have fun doing your little homework of floating pennies on tinfoil. And I would like to thank Kaylin for doing the eye patch challenge. I will add your information to the evidence we are gathering at the testing evidence we're gathering at school. Also, who was it? Micah. Micah sent me a build your own controller video game or app or something on Scratch. Micah, I haven't looked at it yet, but I did get it. That will be added into the pile of potential winners for a pirate controller made by you and me. Okay? Ruby, hello. Good to see you guys, all right? Okay, so that is it for today. I hope you guys have a good time making some pirate tinfoil boats. Tell me how many pennies you made. All right, take care.